I welcome you all again to this physics session. I am Dr. Sumit Bhatnagar. I am a faculty member at Prepaze. Today we will be going to discuss further the chapter forces. So today we'll be discussing the inclined plane problems and the elevator problems, which are most commonly asked in examinations. And so before starting, I want to introduce you to Prepaze. So Prepaze is basically an online platform which delivers good education at the comfort of your home. You can learn, clarify all your doubts from educators like me, which are experts in their respective subjects from all over the world. You can choose your own timings according to your convenience. And so I will just tell you, please go to the website and book a free trial, okay, and check it by yourself. If you like it, you can continue. Let's continue with the topic forces. So first thing we will be discussing now is the question based on the inclined planes. Okay, so basically we will be discussing inclined plane problems. All right. Last class, basically we discussed the normal ground, another ground object is kept on the ground, and the pulley problems. Okay, now we have inclined plane problems. So these are one of the most commonly asked problems we have. So inclined plane basically something like this. Suppose this is an inclined plane over here. Let's say it is inclined at an angle of that is, you can take any 30 degrees. Suppose, let's say that. The first question basically goes like this. Suppose, let's say there is a block of mass m. Okay, mass, you can take it, let's say is 4 kg, and which is kept on the inclined plane. Okay, it is a frictionless surface. Frictionless inclined plane. Block is mass is kept. Now, the very basic question, what is the acceleration of this mass? Again, if you know it, please do try it and give it a shot and then check the answer. So, see, the first thing whenever we are going to proceed, last class also I told you for the motion question is the free body diagram. That's extremely important because you are doing such kind of problems for the first time. It is extremely important. Or even if you are good in this kind of problems, it is better always suggest able to draw a free body diagram and then proceed. So what do we have over here on the 4 kg block? Firstly, there is a weight which is mg. So I will take, let me write it mg only. This is exerting, basically being exerted. So over here mg is basically what? 40 Newton. Why? Because g I'm taking as let's say take it 10 meter per second square. All right. So there is an mg force which is vertically downwards, and there is a normal reaction force. Like it is not upward. Okay, normal reaction force is not like this. That is incorrect. It is always, I told you when we're discussing the forces, it is always perpendicular to the contact surface. So this is the situation over here now. And is there any other forces? No. Right. There are no other forces being exerted. So these are the only two forces on the 4 kg box. All right. Very good. Now, where the object can move? That's the question. Where will the object will go? Obviously, will go along the incline only, right? It will move only along the inclined plane. Cannot go upward or anywhere else, right? It will obviously, if you keep something on an inclined plane, it will basically go down along the inclined plane only, right? So that will happen. So what we need to say that the acceleration of the block is along the incline. The acceleration is along the incline. If the acceleration is along the incline, where the net force should be? Net force F net should also be along the incline. That is basically Newton's second law. We have discussed that. F net should be along incline. I told you that if according to Newton's second law, the net force direction is the direction of the acceleration. Wherever the acceleration, the net force has to be along that direction. It's along the incline. But is there any force along the incline right now? No, right? No. N is there, which is perpendicular to the incline, and mg vertical onward. That means what? I have to take components of mg. That's very important. Take the components of mg. Basically, what I have to do, I can draw a line along the incline. This is a dashed line, which is representing the incline. Over here, if you see very carefully, the angle, which is very important. Let me just draw it first. Suppose, let's say, this is the inclined plane over here, and this is the perpendicular to that. This angle is the theta, which is 30 degree over here. It is same angle as the inclined plane over this. Basically, we get from trigonometry. Sorry. So this angle will be 30 degree right now. It is same as the angle of that. We can get it from trigonometry. Now this component will be what? Mg sine theta 30 degree, and this component will be mg cos 30 degree. Wherever the theta degree, we have to make it inclined. For these components, you have to be very good with vectors. So vectors need to be very good to make the components of the vectors and all those things need to be strong enough to make the components like this. So we have mg vertically downwards. The components will be mg cos 30 and mg sin. Why cos? Basically, if you draw the triangle over here, this triangle, right angle triangle, this is your mg, right, which is your component, okay, which is the main force basically, and you have to make the components of that, which is along this incline. This component is theta, this angle is theta, so this angle will be mg cos, and perpendicular to this will be mg sin 30 degree, and that is how basically we make the components of the force. This is it. So now what do we have over here is mg cos 30 is there and mg sin 30 is over here along the incline. That means what? What is the force which is taking the block along the surface is the mg sin 30 degree. The normal reaction force is balanced with mg cos 30 degree. The normal is balanced with mg cos 30 degree, which is basically this. Why we are balancing it? Because what is happening, the block is not moving vertically in the direction, it is only going in this direction. That is why n is equals to mg cos 30 degree over here. All right, and what is the net force? The F net now, that is along the incline, it is only mg sin 30. If you want to remember it, it is always wherever theta of an inclined plane is given to you, mg component along the incline, it is always mg sin 30 theta degree, and perpendicular to it, okay, it is always mg cos 30 theta degree, sorry. Okay, if the angle of the inclined plane is theta. So F net is this. Now what is F net according to Newton's second law? It is F net equals to ma. This cancels out. So what is the acceleration now? It is g, and sin theta we know is half g by 2. That is 5 meter per second square along the incline. So that's how we solve this question. Now suppose if I now introduce friction in this. Okay, let us say that apart from, since I initially gave you there is no friction, right? There is frictionless surface. Now if suppose you introduce friction, let's say I'm giving you mu. Okay, not mu s or mu k, just normal mu, which is let's say 0.2 you can take. Okay, or let's say 0.1. Very simple case I'm taking right now. Let's say mu is 0.1 for the surface is given to us. Now in the free body diagram, I have to also include a friction force, which is where? Acting backward, because friction opposes the motion, right? So it will act where? The friction will act over here in this direction on the block. Friction will try to stop it. Now, what is friction value? Friction is, I told you, right? What is the mathematical formula of friction? It is mu into n, normal reaction force. Now, what is mu? It is 0.1. And what is n? N is m, not mg. Many students make a mistake. They take n equals to mg. It is not mg. It is mg cos 30 degree. This you need to know when you are taking an inclined plane problem. So m is basically 4. G you can take 10. And what is cos 30? It is root 3 by 2. So basically this cancels from here. This is 2 root 3. So this is 2 root 3. That is the friction force acting. So if I want to write the net force on the block, what is the net force now? Over here we have mg sin 30, which is what? Basically m is 4. So it is 40 by 2, it is 20, right? So it is basically 20. Okay, mg sin 30 value is what? 20 newtons. All right, minus 2 root 3, which is basically from the friction. This is equals to m. So what is m? M is over here is the mass of this, which is 4. A is the acceleration. So you can just calculate it. It's okay, what you can leave it right now. It is 4. So this is the acceleration value. Over here we have a meter per second square. All right. These are the very basic, I will say, the problems in inclined plane. The problems get extremely difficult and very conceptual, as like obviously we won't be able to discuss all of them. This is just to these sessions which I'm doing right now, it just to make some of the concept, just to make you feel of what are the things and what are the concepts involved. So in a regular session, in regular classes, obviously I will always go very deep to make you understand each and every concept of different problems involved. These are the inclined plane, different kind of inclined plane problems you can be expected to get. After this, basically what we have is another common example which we take is an elevator problem. So what do we have over here is our elevator problem. Elevator problems. Now, what are elevator problems? Okay, let us see that. Now, this is very common observation you must have felt when you go to very high-rise buildings, not to 3 to 4, 5 floors. That is not where you can see this observation. When you go to very high-rise buildings or with an elevator, or you come down, basically, you feel that something is not, you feel that something is happening with your body, right? There is some phenomena is happening. So what is happening over here, that is basically we'll be going to discuss. What changes is the weight of your body, and that is basically is the concept involved when we do the elevator problem. Let us discuss that and see what happens. So suppose, let's say we consider an elevator, three elevators we consider, three situations. So in the first situation, let us say that the elevator is going upward with an acceleration A. Second situation, elevator is going what, downward with an acceleration A, constant acceleration. And third situation, it is acceleration 0, that is velocity is constant. All right, three situations I have taken. Now, suppose a person is basically standing on an elevator and there is a weight balance on basically on which the person is standing, right? All three same situations are there. Person is standing on an inside an elevator with a weighing balance. Okay, this is basically the weighing balance of the person. Now, what does the weighing balance gives you? So weighing balance basically gives the weight of the person, right? If you suppose, let's say, stand on how you get your weight. This is a weighing balance, and suppose a person is standing on it. So the weight of the person is acting downwards, we know, and there is a normal reaction force which is acting upwards. So the person is exerting a weight of mg, right, on the weighing balance. So according to Newton's third law, there is an equal and opposite force, which is basically N exerted on the person, and that's why N will be equal to mg. So the normal reaction force of the weighing balance on the person, okay, N of the weighing balance on the person will be equal to mg, which gives a weight, isn't it right? So this situation is over here. So I'll just rub this first. Now see the first situation. What is happening? The lift is going upwards, so obviously the person is also going upwards, right? Person is also going upward with an acceleration. Now, when you draw the free body diagram of the person, FBD of person inside the lift, you can see that there is normal reaction force on the person N due to the weight balance. His own weight mg is there, and obviously the person is also going with the lift, right? So where is the acceleration of the person? It is upwards. So where is the net force? Net force will be on the person is n minus. Why I wrote n minus mg? Because again, go back to Newton's second law, where I told you that the net force is always in the direction of the acceleration. Clear? Right? So n minus mg, this is equals to what? M into a. So what is n now? M g plus a. What is happening now? Mg was the weight, so I can also write like this: mg plus me. Mg was the weight originally when the person was on the ground, plus me. That is, something is being added to the weight of the person. N gives what? N gives the weight of the person, right? Basically the apparent weight. You can say that. It's give the apparent weight. N gives the apparent weight. So what is happening now? When you're going in the lift with an acceleration A going above, basically going in the upward, okay, the elevator, your weight will increase, which is basically mg plus m. All right, that is basically happening. Now consider a situation where A is basically going downward. Same one, mg, same thing, mg will be downwards, n will be upwards. What is the net force now? Mg minus n equals to ma. Because why I wrote mg minus n? Because the acceleration is now downwards. So what is m now? Mg minus ma. Something is being subtracted from the actual weight. That is, now person, the weight will be less. Person's weight will be less. That's why when you go down with the constant acceleration in the lift, your weight decreases a bit. What is happening in normal situation? Normal situation, obviously A is 0. So N will be equals to mg. So this is basically different type of situations can arrive inside the lift. Obviously here also, there are not a lot of variety of questions like an inclined plane, pulley, but yes, definitely there are 2-3 more variety of questions which can be asked upon this concept. So I will stop over here now. That is basically all the forces. This is just a very basic concept I gave you of the forces and what are the different type of questions you can expect. There are a lot more concept involved depending on what different questions we have. I really suggest you to book the free trial class. Also, you can study that. Okay, to concept. And if it is you like it, you can book the regular sessions in the going to the Prepaze site. So hope you like this session. Please do check the Prepaze site and book a free trial class. We'll meet you in the next session. And the next session, we will be starting off with work, power, energy. All right. So hope you like this lecture. Okay. Then see you in the next class. Bye.